Hey guys, so in this screencast I'm going to talk a little bit more about the .exists notifications that come out of OpenStack. I've talked about this before in other presentations, and I'm just going to touch on it briefly, and then I'll show you how we're proposing to solve this problem with StackTach.v3 in Oahu, the Oahu Pipeline processor, and in Winchester. The two are going to come together at some point soon. So let's just talk a little bit first about these notifications, these special .exists records. There's already a whole lot of notifications that come out of Nova, for example. Every OpenStack project generates notifications, most every project anyway. And most of them are around things like create, resize, rescue, all these sort of things. There's a special notification that happens down here on the bottom. This compute instance exists. And that is used whenever the launched at date for an instance changes. The launched at date is a part of the notification that says this is when the instance came alive. So for billing purposes, that's a very important field to know, because you want to start billing as soon as the thing starts consuming or starts generating CPU for you. There's another time when exists records are generated as well. Even though the launched at didn't change, we still want to get a .exists record at the end of every day for every live instance that's in the system. So we might have created an instance a month ago and not done anything with it. It just runs like it should. But for billing purposes, we need to know that that thing is still there and that it's still something that can be billed for. So Nova will generate a compute instance exists notification at midnight for every active instance that's in the system. Other OpenStack products will probably do the same thing in some fashion, but this is certainly the main one for Nova. And we want to be able to gather those up, as well as gather up all the other operations that happen to that particular instance throughout the day, so that we can reconcile the two. So if a resize happened or if a delete happened, and then at the end of the day we get this .exists record, we want to be able to look at the transactional events and compare that to the end of day usage event. The end of day usage event also includes some other data like bandwidth usage and things like that. So it's a very important notification to deal with. It's also a hard one to deal with. We were doing .exists processing in StackTach.v2, and it was a very hard-coded, laborious task. And now we're trying to do this in a generic fashion in StackTach.v3. So we've got this working now in the Oahu Pipeline, and I'm going to walk you through how we do it. So, like I said, at the end of the audit period, we get all these sort of things. So let's just look again at how this fits together inside of StackTach.v3. We've got OpenStack, some OpenStack service here that's generating notifications onto the pipeline. We've got the Yagi event workers that are consuming these notifications off of the queue and sending them down into a variety of different handlers. We've got a handler that sends them out to Atom Hopper. We have a handler that writes it to a local file in its raw form with all the gory details, and then uploads that to cloud files. I've given you a demo of that before in some of the earlier screencasts. We can send it into StackDistiller. So StackDistiller is an interesting one, because that's going to take this big, beefy notification with hundreds of key value pairs in it, and we're going to extract just the juicy bits that we're interested in for our pipeline processing. So from there, we'll take that and we'll do one of two things. We're still sort of working this out just yet. We're either going to republish that reduced notification back into Rabbit and then consume it on a different queue. So we'll publish it to a different exchange and probably consume it off the StackTach whatever queue, using the same mechanism, using just more Yagi workers and having other handlers over here to deal with it. We might send it out to Kafka, which is a higher performance queuing system. We might just have the StackDistiller daisy chain right into the pipeline processing code. So for this demo, I'm going to show you Yagi event talking right to Oahu with a specific Yagi handler. but you'll get the idea. It's going to be a very minor point how we differentiate these things. So like I mentioned, we do have a couple of pipeline implementations right now. One is Oahu, which started off as just something that we could use for testing purposes to make sure we had everything going, but it's sort of evolved to become an actual fully evolved pipeline system. But it uses MongoDB primarily, and it doesn't have any YAML-based configuration, so everything is hard-coded in it. Winchester, however, is MySQL-based. It's we're expecting to get better performance from that, and it is fully YAML-based. So all the pipeline definitions and the operations for the distiller and everything will be accessible from Winchester, which makes it nice for the API. For Oahu, we wouldn't be able to configure through the REST interface because we can't send code across the REST interface. But with Winchester, we would be able to change the pipeline definitions. So there's going to be these two things are going to come together in some fashion. We're going to steal pieces from Oahu. We're going to use parts of Winchester, and we're going to merge these things, and that's going to happen. You'll see that in subsequent branches and subsequent screencasts. So what'll happen is, what I'll demo right now is basically events being consumed by Yagi. Oahu is going to read them and is going to work with MongoDB in this case. And we're going to create all these different streams for end-of-day exist records. So just to recap how this thing works, we've got a pipeline stream is just a bunch of related events that are related by some criteria. So all these events are coming in, and they might get dumped into some big stream 1, 2, 3, 4, 5, whatever it is, as related events. And then when something happens at the end of this, like maybe it's time-wise, or maybe it's this is a special certain event that triggers, that signifies the end of a stream of related events, and this thing becomes triggered. So every stream, there's going to be thousands and thousands of these streams that are active at any one time that are being gathered up and collected. And they go through this little state machine down here. So this is a stream state. So any one of these streams you see up here can be in the stream state. It can be collecting, which means it's gathering events, and events are getting added to this stream definition. When the criteria has been met for triggering, then it goes into the ready state, and now we're ready to actually do some processing on it. So now we've got a sequence of events, and we want to do something with it. So we don't have to do complex database queries or anything. We're just going to be given, let's say, the 20 or 30 events that we really want to work with, because we know that we've gathered them all correctly. So we have multiple workers that can look for these ready streams and do some work on them, because they could be quite expensive operations. So we have multiple workers, and there's a locking mechanism that says, okay, I'm working on this stream, you leave it alone. And I demoed that in the previous streamcast. If you're interested, I'll touch on it again in this one. And then once it's done, it goes into the triggered state. So now it's in the triggered state, and now the work is being done on it. And if it finishes correctly, it goes into a completed state, and if it fails, it goes into an error state. So what we can do is we can find out what the error is, fix it up, and then take it from the error state back into the ready state, and it'll still operate all the way through. The reason is that these operations for processing are all idempotent. So we'll build up all the things that we want to do, and then just write them out at the end. And if anything fails along the way, then there's no harm, no foul. It's a guaranteed once operation, at least once. And if it's completed, then it can just go on and get purged afterwards. We can just nuke it. And the complete operation could be something like generate a brand new event, for example. So that's how that sort of thing works. Okay, so let's just, I think it's there's one other part. Like I mentioned in the previous screencast, we do have multiple workers here that are reading from the stream definitions and doing work on them. So these are the daemons that look for expired or ready streams, and then they process the ready streams, and then they purge the finished ones. But you'll see that in the demo here. So I think that's enough of the overview. Again, go back to the previous screencasts if you want to get some more detail on that. So let's just look at the code here and how we're going to I'll show you this little demo. So we will just load up the configuration file first, which is going to be our, like I mentioned before, for Oahu, we've got all of our configuration done in code, which is different than Winchester, which will use YAML definitions. But for coding purposes and for development purposes, this is actually a little bit easier. And one of the things for this config object is a method called getDriver, which is going to return the pipeline driver that Oahu should use, in which case this will be a MongoDB driver down here. And passed into the MongoDB drivers is a set of triggers. It's a list of triggers right here that are pipeline definitions. And in this case, we've got two. We've got one pipeline which is going to collect up all related, which is going to gather up all the all the events that are related by a single request ID. So in this case, every event has a key value called context request ID, which is a UUID for, which is going to be the request ID for every related set of events. So if I do like I just mentioned in the Node.js demo, if I do a create instance operation, it might actually generate 20 or 30 different events, but they'll all be tied together by this request ID. And this is one that I demoed in a previous screencast, where this is a pipeline that says gather all the events that are related by request ID, and when we've gone 60 seconds without seeing another one, then trigger that pipeline. So that's one that I've showed before, and go back to that screencast for more details on that. But this is the one that's really interesting now. This is the one which is the end of day exists event. So what we're doing here is we're looking for all the events that have the same instance ID, instance UUID, and they have the same audit bucket. So this is obviously a trait that's in the event in the payload dictionary, and it's called instance ID. And then we have another one which is called Audit Bucket. Now, Audit Bucket doesn't exist anywhere yet. It doesn't exist in a notification. This is one. It's sort of like an ephemeral trait that we're creating on the fly, and I'll show you how we do that. But these two things together define what this stream definition is. So the Audit Bucket is just the date portion of the date time field for an event. So if an event occurred at 3 o'clock in the morning, whatever that day was, if it's a Tuesday, that's the bucket that it goes in. So now we're creating buckets of related instance ID streams. So all the events for this instance ID on a Tuesday, and then another stream for all the events for this instance ID on a Wednesday, on a Thursday, like that. And we'll end up with these different stream definitions. And the thing that determines the end of it is this criteria called end of day exists, which means that when we see this event, and there's a bunch of other criteria around it, so when we see that event and some other stuff happens, that's going to trigger the stream. And I'll just go into the gory details of how that happens. So let's first look at where this audit bucket came from. What I will do is just show you the Yagi handler. So this is what gets called from Yagi when an event comes in. The first thing that we do is we've got a full event that just came in. I pull out the payload from it, which is part of the nested structure. I take out the timestamp for the event and parse it, so now I've got an actual Python date time string. And then I create this other variable called audit, which just by default takes the date. But if we happen to have this one field in here called audit period beginning, when we do an audit, there's two keys that we get in the payload: audit period beginning and audit period ending. And they only exist in the .exists records. They also exist in the .update records, but for audit purposes, it's really in the .exists event. So if we do have that, then we'll parse it out and we'll use that as our audit period. So now we'll tack in this new trait into the event called Audit Bucket, and it's just the date portion of it. So now we know which day this thing belongs to. The thing that makes this a little tricky is audit period beginning and audit period ending will be at the midnight hour for a 24-hour period. So let's say this is the dot exists for a Tuesday, then we'll see that it's going to be Tuesday at midnight to Wednesday at midnight. So the time will be 0000 in both situations. So that's why we're looking at the beginning, because we want to make sure that this dot exists record goes in the Tuesday bucket where it belongs, even though the event was generated on the Wednesday. So if I just looked at the timestamp, it would be Wednesday and it would go in the wrong bucket. If I look at the audit period beginning, it'll be for Tuesday, goes in the right bucket then. So this is the audit bucket, and that's why it's different than the timestamp. So now we've created that field. So now let's just look at that criteria. If I go back to here, remember we had this end of day exists criteria for triggering it. So let's just see how that works here. So that would be in a file, in this criteria file, and these are plugin based, so these can live anywhere. These are just some stock ones that we're including with Oahu. So we already saw the inactive one that says if we've gone a certain time span without seeing another event, then yes, it should fire off this stream. If it's a certain event type, we can trigger a stream. Here's an AND criteria. It says, you know, if this and this and this and this all happen, then we should fire. And here's the one that we're interested in, this end of day exists event. And the should fire for that just looks at it and says, okay, if we don't have a last event, so normally we get passed in, what should fire gets passed in a stream object. And the stream object says, you know, here's the name of the stream, here's the ID of the stream, blah, 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 some basic information. And it can also potentially store all the events in the stream so far, but we don't load those by default because that could be a little bit of a costly operation, especially if we're doing this check on every stream in the system. So we're going to lazy load this thing. We'll load up the events. Providing there's some in here, then we're interested in it, and we'll just have the last event. We'll just pull the last event off the list of events if it wasn't passed in already. Depending on how the stream processing gets called, we may have the last event or we may not have it. So if the last event isn't the one that we're looking for, in this case compute instance exists, then don't trigger. But now we can look at audit period beginning and audit period ending. Okay, if we have both of those, then we're going to continue on. If one of those is none or missing, then we're going to bail out. We'll parse them, and then we just do this is 0 hour check to make sure that both of these are time 0. And if they're both time 0 and its compute instance exists, then we know that we've got a proper .exists record and we can fire off that stream. So it's a little bit complicated. There will be, in Winchester, like I mentioned, you'll be able to define this sort of logic in a YAML grammar, but for now we're just doing it for with code just to prove the concept. So now we've got these three things. We've got our config file, which says these are the two streams that we're interested in. We're going to do both of those. We've got our criteria, which says this is when we're going to trigger off of these streams, and we've set up our events as they come in to give us all the fields that we want. And again, this manual manipulation of the event that we're doing right here will be done through the distiller, through the stack distiller library, and again, that's definable as a YAML grammar. So a lot of this stuff is going to be data driven as opposed to code driven. So let's take that and start this thing up. Now this does sort of happen quickly, but I'll show you what's happening as we go through it. And okay, so this is going to start the sandbox with the screen session that has all the different components running in it. Okay, so first thing we did here is in the first window we've got Notogen running, and we just fired off all of these different events. And if I scroll back a little bit on this, we'll see that at the midnight hour, yeah, right around here, just around midnight, so as we transition into the next day, the first thing that happened is we got a whole bunch of these .exists records came through for all the instances that happened. So in this case, we got probably about 8 or 9 of them. because there was only about 8 or 9 operations at that point. There wasn't a whole lot of time difference in between there. And then we had a whole bunch of events that happened after the fact. So we're going to see, in this case, we're going to see a bunch of events that happened on the 20th, and then a bunch that happened on the 21st. So a lot of these streams aren't going to finish because we only generate 24 hours in this example. So if we go into the next 2 screens, these are the Yagi workers. There's no real output for that, but they just gathered up all those events and they dumped them into the pipelines. Quincy, we can skip for now, and now we've got the first worker. So the first worker is the expiry check, or the one that's looking for any pipelines or streams that are ready to trigger. So the first time it ran, this one runs I think every 2 seconds, or no, every 20 seconds. This is running every 20 seconds. Of course you can configure that to do what you want. But so on the first check it didn't have anything in there that it wanted. The next time it went through it found 9 that were ready. So those are the 9 .exist records, or the .exist events that triggered off those streams. So we had 121 streams. We found 9 of them that were ready, and then on the next check, we see that we went down to 112 streams that were ready. This data over here, because we could have potentially thousands and thousands of streams, it does a paging system through it. So there's an offset and a limit for the database query for determining. So we were going to try and grab 1,000 of them. In this case, we only got 121 of them. But it's using the offset is 0. Try and grab 1,000 of them, but in this case we only got 121 of them, which is fine. This is just a small little test, but normally that would be a nice sized chunk to work with. And then another 20 seconds went by, nothing happened. Another 20 seconds went by, but then on this one here we've gone past our 60-second expiry for the other stream. So we saw that there was 56 streams that were ready for processing. Right here, these are requests that came through. So these are related request IDs, and they all went ready. And then after that, we've got another 56, these are the remaining end-of-day exist streams that are running. So these are the ones that are looking for on the 20th. I think it is the 20th, or yeah, these are the ones for the 20th. So these aren't going to expire. These are just going to run and run and run, waiting for the .exist events to happen. In this case, they never will occur. But so now we've got 9 and 56 streams that were ready for processing. So let's look at the next two. The next 2 tabs down here have the 2 ready workers that are chugging away here. And let's just scroll back up and have a look at the top. Okay. So we've got, right, so this is a polling rate of 1 second, and as we were coming through, we're doing this in blocks of 100. So same sort of thing, offset, limit, size. So we have an offset of 0. We're grabbing a block of 100 to do some processing on them, and we got none back. But then we got down here, and here's our 9 of our end-of-day exists streams that were found, and they all transitioned happily over into the ready state. So we see that we processed 8 of them. 1 of them was locked. So because we had got 2 workers running, and they both started up at around the same time, they both tried to grab that same stream at the same time, and one of them bailed out and said, okay, you've already been working on that one, so you can have that one. So out of the 9 that were ready, it got 8 of them. And if we scroll down a little further, then we see the rest of this block here. This is when it's doing the request ID stream, and these are all the streams that it found. They went into the ready state. There was 29 that it processed, so there's 29 of those right here. 27 of them it couldn't get, it was locked. So that's the 56 that we saw, but it was pretty evenly divided between the 2 workers. And if we go over to the next tab here and look at that, we should see just the opposite here, right? This will be, these are the locked ones from the other one. So in this case, we had the 1 end of day exists that this one stole from the other worker. And down here, we've got the other 27 operations here, 27 streams, and the 29 were locked by the first worker. So it did the right thing. and now we'll just go to the last tab, which is the completed. This is the other daemon that runs that looks for completed streams, and let's find it here. Okay, so this one here is just saying, okay, this is the end of day exists, all 9 of them finished and they got purged, and then all 56 of them were completed and they got purged. So when we go back to the ready workers, this is the callback that's sending this message out. That's just saying, I'm doing some work on this stream. Now really it could be doing whatever we needed to do, like sending new events or updating some metrics or sending out something to a metering program or something, or creating a report. But right now we're just printing a little statement out here. So there we go. We just did an end of day exists processing. If we were to look at the events in that stream, we would see everything related to one particular instance ID. So it could be, resizes and creates and deletes and all those things. And from there we can reconcile that against our end of day .exists record to make sure, does the bandwidth add up, does the usage add up, do all these things reconcile. And that's pretty well it. So anyway, that's a big step for us. The end of day .exists stream is our #1 use case, and because we can actually do it and get the data that we need in a reliable fashion, that really sets us up well for all the harder stuff that we want to do. If we can do this one, we can certainly do a lot of other streams. So again, if you have any questions, just add some comments to the comment field below this video, and we'll be sure to answer them. Or you can just catch us in the IRC channels or wherever you like. Okay, cheers, bye.